Why astronauts can't cry in space, and other bizarre facts. When Canadian astronaut Chris Hadfield experienced the sting of tears in space, he discovered something peculiar. The tears wouldn't fall. They simply accumulated around his eyes like a liquid bubble, creating an uncomfortable, blurry mess that required a towel to remove. This seemingly simple observation opens a window into the bizarre reality of life beyond Earth's atmosphere, a place where the fundamental rules we take for granted simply don't apply. The physics of space tears. In the microgravity environment of space, tears still form when astronauts' eyes are irritated or when they experience strong emotions. The lacrimal glands function normally, producing the same salty mixture of water, oils, and proteins. However, without gravity to pull them down your cheeks, tears have nowhere to go. They pool around the eyes, forming an increasingly large ball of liquid held in place by surface tension. Astronaut Andrew Fustel experienced this firsthand during a spacewalk when anti-fogging solution got into his eye. Unable to wipe his eyes through his helmet, he had to endure the accumulating tear bubble until it grew large enough to reach his nose, where he could absorb some of it into his sinuses. The experience highlights how even basic human functions become complex challenges in space. The smell of the cosmos. Perhaps one of the most unexpected discoveries is that space has a distinct smell. Astronauts consistently report that after spacewalks, their suits carry a peculiar odor, often described as resembling seared steak, hot metal, or welding fumes. Some compare it to the smell of gunpowder or burnt almond cookies. This phenomenon likely results from high-energy particles called ions, which stick to spacesuits during EVA's, extravehicular activities. When astronauts return to the pressurized environment and remove their helmets, these particles react with oxygen and nitrogen in the air, creating the distinctive metallic aroma. NASA has even commissioned the creation of a perfume called Eau d'Espace to help train astronauts for this sensory experience, growing pains and shrinking bones. Without Earth's constant gravitational compression, astronauts' spines elongate, making them grow up to 3% taller during extended stays in space. The vertebral discs expand without the usual downward pressure, stretching the spine. Scott Kelly grew 2 inches during his year aboard the International Space Station. This growth isn't permanent. Astronauts return to their normal height within months of returning to Earth. However, this spinal freedom comes at a severe cost. Astronauts lose approximately 1 to 2% of their bone mass per month in space, particularly in weight-bearing bones like hips and legs. This accelerated osteoporosis occurs because bones, without the stress of supporting body weight, begin breaking down faster than they rebuild. Some astronauts lose more bone mass in 6 months than postmenopausal women lose in 2 years. Fire behaves like alien magic. In microgravity, fire becomes almost unrecognizable. Instead of the familiar teardrop shape caused by hot air rising, flames in space form perfect spheres. They burn at lower temperatures, appearing blue rather than yellow-orange, and can sustain themselves at temperatures that would extinguish flames on Earth. The FLEX, flame extinguishment experiment, aboard the ISS revealed something even stranger: cool flames that burn at temperatures as low as 200 to 300 degrees, taste and smell go haywire. Many astronauts report that food tastes bland in space, requiring extra seasoning and hot sauce to seem palatable. This isn't just psychological, it's physiological. In microgravity, bodily fluids distribute differently, with more fluid shifting to the upper body and head. This creates chronic nasal congestion similar to a head cold, dulling both smell and taste. The ISS is stocked with hundreds of hot sauce bottles and other condiments. Astronauts often crave strongly flavored foods they might not typically enjoy on Earth. Shrimp cocktail, with its intense horseradish kick, has become an unexpected space station favorite precisely because astronauts can actually taste it. Sleep becomes surreal. Imagine trying to sleep while falling, permanently. That's the reality for astronauts, who must strap themselves into sleeping bags attached to walls to avoid floating around and bumping into equipment. Without the natural light-dark cycle, the ISS experiences 16 sunrises and sunsets every 24 hours, circadian rhythms become completely disrupted. Many astronauts report vivid, intense dreams and frequent awakenings. Some experience the sensation of falling just as they drift off to sleep. Ironic, considering they're technically in constant freefall. NASA uses special LED lighting systems that change color temperature throughout the day to help maintain some semblance of normal sleep patterns. Footprints that last forever. On the Moon, where there's no atmosphere, wind, or water erosion, human footprints will remain visible for millions of years. The boot prints left by Apollo astronauts in 1969-1972 look exactly the same today as when they were made. Only micrometeorite impacts will gradually erase them over geological timescales. This permanence extends to everything humans have left on the lunar surface, from scientific equipment to golf balls to family photographs. The Moon serves as an eternal museum of human exploration, preserving our first steps beyond Earth in perpetuity. The spontaneous welding problem. In the vacuum of space, two pieces of the same metal can spontaneously weld together if they touch, a phenomenon called cold welding or contact welding. On Earth, oxidation creates a barrier layer preventing this, but in space's vacuum, perfectly clean metal surfaces can fuse at the atomic level. This created real concerns for early spacecraft designers. Moving parts had to be carefully designed with different materials or special coatings to prevent mechanisms from permanently fusing. The Galileo spacecraft's high-gain antenna famously failed to deploy properly, possibly due to cold welding of its components during the years-long journey to Jupiter. The profound strangeness of space. These bizarre realities remind us that space isn't just a place with different scenery. It's an environment where fundamental assumptions about existence break down. Every adaptation astronauts make, from learning to cry into towels to seasoning bland food, represents humanity pushing beyond the boundaries of our evolutionary design. In documenting these strange truths, we're not just collecting curious facts, we're mapping the very limits of human experience and adaptation,